Hello everyone, let us discuss about all pair shortest path using dynamic programming. So here we have an algorithm for all pair shortest path where the input is cost matrix and the number of vertices, and the cost matrix will be copied to A. So initially we copy the cost matrix to A, then each and every matrix will be evaluated with principle of optimality equation K times. So let us evaluate the problem with given example, right? So let us evaluate with a given example, then we will scan the algorithm. So what do you mean by all pair shortest path? Between each pair of vertices, we want to calculate the shortest path. That is called as all pair shortest path. So let us take this small example here, the example. So the given graph is converted to adjacency matrix. That adjacency matrix is copied to A matrix. Now let us solve this. So what we do is initially we want to calculate the principle of optimality equation, which is nothing but So A of I comma j is equal to minimum of A of I comma j comma A of I comma k plus A of k comma j. So here we are simply doing what? Instead of traveling from I to j, we are calculating the cost between I to k and k to j. So k is an intermediate vertex. So in each and every pair we want to check, is there any direct difference between direct path and indirect path cost? If it is there, we will update it. Now let us calculate this. Now assume that the given graph is this, which is converted into adjacency matrix. Now let us start solving this. Now initially the A0 will consider, this is A0. Now we convert this into A1, A2 and A3. Now first let us calculate A1. So in the A1 what we do is, we want to calculate y of 1. So when we take A1, the first row, first column values will be no change. So let us write as it is. So 0, 8 and 5. And the first column 0, 3, infinity. Of course we have no change in the diagonal because there is no self edges as it is. Now the remaining places you have to check. So what are the remaining places here? If you observe 2, 3 and 3, 2. Now let us start calculating this. So A of 2, 3 is equal to minimum of A of 2, 3, A of 2, 1 plus A of 1, 3. That means what? Instead of traveling from 2 to 3 directly, we want to travel from 2 to 1 and 1 to 3. So what is the cost of A of 2 to 3? The A of 2 to 3 cost is initially infinity. Now I comma k. 2, 1 cost is what? 3 plus 1, 3 cost is 5 and the cost is 8. So between infinity and 8 is the minimum one. We'll update here. So the updated cost will be written like this. We will mark it. Now let us calculate the next one also similarly, right? So A of 3, 2 is equal to minimum of A of 3, 2, A of 3, 1 plus A of 1, 3. So what is 3, 2 cost here? Initially 2. And what is 3 of 3, 1 cost is what? Infinity plus 1, 3 cost is 5. So the indirect cost is more. Let us write as it is. Now the A1 we have completed. Now let us calculate A2. So for A2, A1 will be the input. For A3, A2 will be input. And for A1, A0 is an input. That means what? K minus 1, K minus 1 and K minus 1. Right? So for kth level, we will take k minus 1 level as an input. Now let us calculate in the further levels. So what are the further levels? Now let us take it as it is. Now let us start calculating this remaining level. Now what is here? Now let us calculate YR2. So in YR2, the second row will be as it is 308 and the second column will be as it is 802 and the diagonals will be same and the remaining values let us calculate, that is 1, 3 and 3, 1, 1, 3 and 3, 1. So minimum of A of 1, 3, A of 1, 2 plus A of 2, 3. Right. So what is A of 1, 3 cost? 1, 3 cost is 5 and 1, 2 cost is what? 8 plus 2, 3 cost is 1, 2 cost is 8 and 2, 3 cost is what? 8, the 16. So there is no change here. Let us keep it as it is. No change. Now next, one more one. A of 3, 1 is equal to minimum of A of 3, 1, A of 3, 2 plus A of 2, 1. So here the intermediate vertex is what? 2. So what is A of 3, 1 cost? 3, 1 cost is infinity. 3, 2 cost is what? 2 plus 2, 1 cost is 3 and the result is 5 and we want to update this 5. There is a change. Right? Now let us calculate the next level A3. Let us calculate the change A3. Now what we do? The last level. The last level is what? Because it is 3 vertex matrix, we are taking 3 times. So n vertex, n times, k vertex, k times. So let us calculate the third time. Now in the third time, once again what we do? The third row, third column, no change. So 5, 2, 0 as it is, 5, 8, 0. Same and the diagonal values will be no change. Now let us calculate the remaining values, that is 1, 2 and 2, 1. 1, 2 and 2, 1. Let us calculate. Now in 1, 2 what is this? Minimum of A of 1, 2, A of 1, 3 plus A of 3, 2. Now A of, what is A of 1, 2? If you look at here, 1, 2 is what? 8. A of 1, 3 is what? 5 plus A of 3, 2 is what? 2. So the updated value is what? 7, which is lesser than the direct cost. Now let us update this. Are we clear? So there is a change. Then one more, the last iteration 2, 1. A of 2, 1 is equal to A of 2, 1 is equal to minimum of A of 2, 1, A of 2, 3 plus A of 3, 1. So what is A of 2, 1 cost? A of 2, 1 cost is 3. And what is 2, 3 cost? 2, 3 cost is 8 and 3, 1 cost is 15. 5 that is 13. So there is no change. So let us write as it is. Now we have completed the activity. Now we got the all pair shortest path cost. Now if you look at the principle of optimality equation, so what is the principle of optimality equation here? A of ij is equal to minimum of A of I, j, A of I, k plus A of k, j. So for kth level, k minus 1 level matrix will be the input. So what will be the algorithm here? We have already seen in the initial video. Now let us write in detail. So how we have written the algorithm? Now please tell me. So the algorithm is what? Algorithm all pair shortest path. The input will be what? The input will be cost A and N. The adjacency matrix. A is the copying from a cost to adjacency matrix. Then n are the number of vertices. Now initially what you do, the cost matrix you have to copy to A. So for that the code is what? Very simple. I is equal to 1 to n do. For j is equal to 1 to n do. We are writing an algorithm notation. Let us write in a simple way. And we are copying what? A of I comma j is equal to cost of I comma j. That means what? We have copied the adjacency matrix to A matrix. Now let us solve the problem using an algorithm. So what we do? Very simple. We have to go through the entire matrix. In order to go to the entire matrix, what do you need to do? For I is equal to 1 to n do for j is equal to 1 to n do. What we have to do? The principle of optimality equation. Yeah. So the principle of optimality equation is what? Very simple. We have already know this. The principle of optimality equation is A of I comma j is equal to minimum of A of I comma j comma A of I comma k plus A of k comma j. Now this code will generate one matrix. How many times you have to do? K times. So for that what you do? You write one more loop which is for k is equal to 1 to n do. So this is an outer loop. This is one more loop. And this is one more loop. And this is the activity you are going to repeat. So as we have 3 loops, so what is the time complexity of all pair shortest path? The time complexity of all pair shortest path is O of n cube, which is deterministic polynomial algorithm, right? So this is about all pair shortest path using dynamic programming. Thank you so much. See you in the next session.